Okay, so for today's topic is about the Laplace transform using the definitions. So actually the Laplace transform is an integral transform. When you can see over here, so this is a definition for the Laplace transform. So any of the function ft here, you do the Laplace transform. So this is the function or the products you get for capital Fs. S is stand for the S domain. So this is the Laplacian operator. So what is actually this mean by? So actually this is the integral transform. So they will make it the complicated the operation become more simple using the Laplace transform from the t domain to the s domain. So this is the definitions. The definition of the Laplace transform. This is the way. So it's the integrate from 0 to infinities, exponent negative s, t, ft, dt. So ft actually is based on the function that you have here. Let's say this is the t, then this one become t. So this is basically an example on what on your mind actually you should have. So this is the function normally that we have from the t domain, we transform to the s domains. So using the Laplace transform, this is called the Laplacian operator. So when you do the Laplace transform from this to here, using the Laplace transform process. So from the t domain, you get for the s domain after you do the Laplace transform. So this is the first example we are looking for. So let's say you have the ft equals to 3. So the 3 is the constants. So you want to find the Laplace transform for the function ft equals to 3. So it's very easy using the definition. So this is the definition that we have here. So this one. So it's simple by using definitions. Okay, so it's very easy. So you just replace, let's say this is the Laplace transform ft just now, right? So t is 3, so just replace this 3 into this one. So this is what I have here. So the same thing goes for you're going to replace in the function this one. So this is what you have over here. So what I did here, I can just do some simplified or just a straightforward simplify, and then I just integrate. So this is what I get here. So once I get this one, so I just proceed for the integration substitutions. So infinity, I can just straightforward substitute to this one, I get this one, and then 0 I substitute to t, so this is a 0. So it's very important you get to know exponent 0 you get equals to 1, and then let's say exponent 1 over infinity, you will get approaching to 0 values. So this is somehow you get this one, and then you just simplify. So this is the Laplace transform for the function ft equals 3. So another example I'm going to show you here is this is another one, is the exponent 2t. So the same things are using the definition, so I just putting back. So this one I just putting in the ft functions, and then because this is the index and index, so this is somehow I do the simplification here. So then I just integrate with respect to t, and this is somehow I get this one, and I just proceed. So once I have this one, so once I have this, I just simplify, I just substitute the infinity to the t, is 0 into this one, so this is what I have here. So of course infinities, this is you get 0, and then this one you get 1. So this is somehow you get the answers. So that means this is the Laplace transform for this one. So I hope you get any idea about this one. So next you can do some exercise regarding to this one. So you can do the Laplace transform to t power 2 or sine 2t. So it's very simple. And there is one question is here. Let's say my ft is the t power 5. So what happened about your Laplace transform? Is that easy? Or time consuming when you have these kind of the things or the complicated form? Or complicated calculations? So that's why we need something to simplify our process, so that's why we have the table like this one, the Laplace transform for the table like this. So this is the Laplace transform table. So for each kind of the function here, so this is another kind of the functions. So basically we have the this is the constant. And let's say you have 1, 2 or 3 or something, the constant k here values. Laplace transform for constant, you will get 1 over k over s. So let's say this is the t power n, so this one we get n factorial over s n plus 1. So it depends on the power here. The same thing goes for this one. Let's say this is a exponent at, then it's 1 over s minus a. So same thing for sin, cos, as well as for the sin hyperbolics, cos hyperbolics. So number 8, 9, 10, 11, actually this is the properties for the Laplace transform that we will go very detailed later after this. And then the last one, this is the Laplace transform for the derivative. So this is also we cover at the end of this topics.